Hello everyone and welcome to Growing 2.2. Learning targets today, we'll be able to recognize an exponential relationship. That is one of our vocabulary words from Investigation 1, an exponential relationship from an equation, and determine the growth factor and the y-intercept. Okay, these are pretty important for this problem to be able to identify those. I'll be able to solve problems involving exponents and exponential growth. These are all of our vocabulary words, most of them coming from Investigation 1. So check back if you need to the Investigation 1 vocabulary and identify what the definitions of these are if you need to. So for 2.2, we just have 4 problems, 5, 7, 8, and 24. So the homework on this one isn't too bad. Hopefully you can get through 2.2 and 2.3 in the same day. This lesson's pretty short, so we should be able to move fairly quickly with it. So 2.2 is growing mold. Yummy. Interpreting equations for exponential functions. So as some of you may know, mold can spread rapidly. For example, the area covered by mold on a loaf of bread that is left out in warm weather grows exponentially. Yuck. So let's take a look at some mold growth. Well, isn't that about the best dinner you've ever felt like having now? So we can see that mold grows fairly quickly. In our problem, students at Magnolia Middle School conducted an experiment. They put a mixture of chicken bouillon, gelatin, and water into a shallow pan. Try this if you want, I guess. Then they left it out to mold. Each day the students recorded the area of the mold in square millimeters. Hey, look, students already did part of the work for you. They wrote the equation m equals 50 times 3 to the d power to model the growth of the mold. In this equation, m is the area of the mold in square millimeters after d days. So what we need to think about looking at this equation is maybe how much mold is there at the end of day 1? If you plug that into the equation here, what would that come up to? What about at the end of day 2? Maybe the end of day 3. Might want to set up a table for this to be able to record your findings. And then do you see any similarities between the pattern of change in this situation and the patterns of change in some of the problems in the last investigation and also in problem 2.1? And try to go ahead and explain or justify that to yourself. Then, once you've done that, part A says for each part answer the question and explain your reasoning. Explain your reasoning, okay? One of the things we have trouble with is explaining. So let's get some practice in here so we're ready for our tests. A1, what is the area of the mold at the start of the experiment? Where could we go to find that? Okay. And then what is the growth factor? What is the area of the mold after 5 days? And on which day will the area of the mold reach 6,400 millimeters squared? Part B, an equation that represents an exponential function can be written in the form y equals a times b to the x power, where a and b are constant values, meaning they're not going to change. They are maybe our base, growth factor, those sorts of things. So in this question for B1, it says, what is the value of B in the mold equation? So up here, what is the value of B? What does this value represent mathematically? What does it represent? And does it make sense in this situation, especially if you had started building your table, and you can look at the pattern and identify that. And then part 2, what is the value of A? What is the value of A in the mold equation up here? What does that value represent again mathematically? What does that identify? So those are the 2 main parts of the problem that I want you to look at, familiarize yourself with, and be ready to discuss with your team when you come to class. Our ACE assignments, again, only 4 questions for 2.2, 5, 7, 8, and 24. All right, look forward to hearing your questions and your challenges in the next class period.